Pre-algebra lesson 120, volume of pyramids, cones, and spheres, and then we're also going to talk about the surface area of pyramids and cones. First, let's start off with the volume of pyramids, cones, and spheres. Before we do that, I'm going to talk about the overall volume equation right here. I got to zoom in because, it's, wait, hold on. Can't give you guys any spoilers, right? So, there we go. I think we've zoomed in enough. So this is the volume of any rectangular solid. We take the area of the base, we multiply it by the height. The area of the base is going to depend on what shape the base is, right? So as long as we know how to find the areas of squares, rectangles, triangles, or any shapes that are a combination of any of those, or even semicircles, we can figure out the area of the base. The height is usually a number that's just given to us. So this is a really good logical understanding of this. Now, when it comes to pyramids and cones, the only thing we have to remember is that pyramids and cones are exactly 1/3 of that volume. So the formula is almost exactly the same, but if it's a pyramid or cone, we just take that volume and then we divide it by 3 in the end. So we can kind of see this in this draw. Whoa, I'm zoomed in too close, little too close. Let's back it up just a little bit right there. Okay, great. So we can see this, that with pyramids and cones, it is 1/3 the volume of the right solid. So all we have to do is the formula that we already know, and then at the very end, divide it by 3, right? Or you can multiply by the fraction 1/3. So with pyramids, cones, make sure you take the volume divided by 3. Now, what if it's a sphere? Now, for those of you who don't know, a sphere is a perfectly round ball, three-dimensional ball, like a bouncy ball, rubber ball. That's a sphere. It's going to be the exact same, except it's going to be 2/3 the volume of the solid, all right? So spheres can be a little bit tricky, but just remember, cones, pyramids, 1/3 area of the base times height. Spheres, 2/3 area of the base times height. And I've got that drawn right here, okay? Now let's go ahead and do some example problems for this. Well, I zoom back out to a normal distance, and let's start off with a cone. Yeah. Now you may be wondering, like, Mr. Claiborne, there's no cone drawn there. Yeah, that's on purpose. Because if you look at problem number 7 on lesson 120, hopefully this isn't your homework. I don't know if it is your homework, then that's fine. But you can see that they're not always going to give you a picture. So if you're on page 381 looking at problem number 7 on lesson 120, they tell you to find the volume of a right circular cone whose base has a radius of 2√2 meters and whose height is 2 meters, rounded to decimal places. There's no drawing. So I need to understand what a cone looks like. A circular cone, so it's got a circle on the base, and it goes up to a point like that, and then so I can draw the cone and then I can start labeling some things. Okay, so they told me that the volume, they told me to find the volume. The base has a radius of 2√2 meters. So when they say the base has the radius, we know the base is going to be the shape of a circle, and the radius is 2√2 meters. Cool. Now they also tell me the height of the cone is 2 meters. Okay. So now I take this information, I'm going to plug it into this formula, 1/3 area of the base times the height. Well, for the area of the base, that's a circle. How do I find the area of the base? Well, that's going to be pi r squared, right? So we'll do area of the base in the green. So let's see here, pi r squared is going to be 2√2 times 2√2. So 2√2 squared. Oh, what is that? Well, I got to think about what happens when I multiply these numbers times themselves. So 2√2 times 2√2. I should remember. Okay, so the 2 times 2 gives me 4, and then square root of 2 times square root of 2. Well, that's a root times itself, so that's just going to be the number 2. Okay, so what I actually have is 4 times 2, which means that the radius squared is going to be 8. Okay, so now I have 8 times pi, so 3.14 times 8. 4 times 8 is 32, carry the 3. 8 times 1 is 8, plus 3 is 11, carry the 1. 8 times 3 is 24, plus 1 is 25.12. Haha! So I've got the area of the base, it's 25.12. Great. Now, what do? I multiply it times the height. So let's go ahead and do that. We'll do this in orange. So 25.2 times the height of 2 meters. That gives me 4, 2, 10, carry the 1, 5, 1, so 50.24. So now I'm at 50.24 for the area of the base times the height. Last step, I can't forget, I need to divide by 3 or multiply by 1/3. I'm just going to divide by 3. So 3 goes into 5 one time. got 2 left over. Bring down the 0. 3 goes into 20 6 times. 6 times 3 is 18. Bring down the 2. Ooh, 3 goes into 22 7 times. 7 times 3 is 21. Bring down the 4. 3 goes into 14 4 times, right? And I get 12. And then it subtracts to 2, and then I got to put a 0. 3 goes into 26 times, but thankful for me, the problem said round the answer to 2 decimal places. Okay, so if I bring my decimal point up, I'm already at 3, so all I have to do is round this 4. So what I'm looking at is I've got 16, so sorry, that might be hard to see. The answer I got is 16.746, and the answer could keep going, but they said I could round to the second decimal place, so that 6 makes that 4 round up to 16.75. All right, so my answer is going to be 16.75 meters cubed, and that is the volume of my cone. Whoa-pow. All right, so area of the base times the height divided by 3. Okay, now let's do a cone, or sorry, not a cone, let's do a sphere. Spheres can be a little bit tricky. Okay, so if you look at the picture of this sphere right here, you have to realize that when they tell you to find the volume of a sphere, they're only going to give you one measurement. The measurement is just going to be the radius. And the reason why is because since a sphere is a perfectly round ball, the height of the sphere will always be the diameter of the sphere, right? So what we can see here is, if you were to look, this middle point of the top point of the sphere actually touches this top circular slice, and the bottom half is actually touching the bottom circular slice of the cone, or the cylinder. So the height of every sphere will always be the diameter of the sphere every single time. Okay, so that's kind of the trick there. So for the sphere, we have to find the volume of the sphere, and it's got a radius of 10 centimeters. So the area of the base is going to be a circle again. So we'll do that in green. So I got to do pi r squared. R squared, well, luckily that's just 100. So that's 3.14 times 100. Why am I doing this? I can just move the decimal place. Okay, so that's 314. Area of the base, 314. Cool. The height. Remember, the height is always going to be the diameter. If the radius is 10, the height or the diameter is 20. So I'm going to do 314 times 20. I'm going to put the 0 on the end so I don't have to multiply by it. I'll just drop it down. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. So I'm at 6,280 centimeters cubed. Wow, that's a lot. Except I cannot forget about the 2/3. Right? Oh, I dropped my pencil cap, or my marker cap. So now I have to take 6,280. I have to multiply it by 2 and divide it by 3. Ugh. Okay, so let's start with the multiply by 2. That's going to be 0. That's 16. That's 4, 5. And then that's 12. Okay, cool. So I'm at 12,560. Now I have to take this number and divide it by 3. 3 goes into 12 4 times. 3 goes into 5 once. Let's see here. Bring down the 6. 3 goes into 26 8 times. Get 24. 3 goes into 26 times. Well, can't get confused with those numbers. I'm at 4186. So I'm doing the thing I always tell you guys not to do. I'm writing sloppy. Don't do this. Learn from my example, children. Write neatly. Okay, 6 times 3 is 18, and then I'm going to get 2 again, which just means that I'm going to get a decimal point with 6, and that 6 is going to repeat. So my answer is going to be 4,186.6 repeating centimeters cubed, and that is the volume of my sphere. So it's not too difficult. Area of the base times the height, and then we just have to take that normal volume answer we have, divide it by 3, or multiply by 2 and divide it by 3, depending on what our shape is. Okay, let's see here. Wow, we're already at 9 minutes. We still have to talk about surface area of pyramids and cones. So luckily, surface area of pyramids is really, really simple. For surface area of pyramids, all we have to do is find the area of every single face. Okay, so there's not a great equation for this. You just count the number of sides and find the area of each side. So I see there's one base, right? So I get that area, and then I've got 1, 2, 3, 4 identical triangular faces. So the area of those triangles is going to be base times height divided by 2. I get that answer, multiply it by 4, and that gives me the walls, and then the base. Add that to whatever that answer is, and that gives me the pyramid, the area of the pyramid. Now every now and again you'll have a pyramid whose base is a triangle. If the base is a triangle, well then you're only going to have 3 faces around the pyramid instead of 4. Okay. Now, what about lateral surface area of a right circular cone? Okay, so for the surface area of a right circular cone, the lateral surface area, or the cone section, that's going to be pi RL. So this is a new formula, right? It is pi RL, right? And that is only the lateral surface area. So if on a cone they're asking you for the total surface area, you would have to take pi RL and add it to pi r squared. Right? And if you remember, the lateral surface area is just the walls, right? So let's talk about pi RL, and what in the world is the letter L? Well, L, as you can see on this drawing, L is the slant height, and that is what your book is going to call it. They're going to call it the slant height or the slant length. Okay, so all we have to do is just plug those numbers into the equations. If we look at example 120.5, they give us a right circular cone. They want us to find the surface area whose slant height is 6 meters and whose radius is 5 meters. Okay, so pi RL is going to give me the lateral surface area, and then I'll have to add that to pi r squared. So they tell me, again, they tell me radius is 6. Oh, no, sorry, radius, whoops. They tell me radius is 5 and slant height is 6. So let's plug this into that equation. If I had to do pi RL, that would be 3.14 times 5 times 6. Well, 5 times 6 is 30. So that's 30 times pi. And then r squared, 5 squared is 25. So that's 25 pi. So I've got 25 pi plus 30 pi. Okay. Let's see here. 25 times 3.14. There's a faster way to do this using some algebra rules, but I realize we're not there yet. So we're just going to multiply this times 3.14 and multiply that times 3.14. And then we'll add up the answers, and that will be my total surface area. Okay, so that's 25 and 7, 15. Whoa, did I do that right? 5 times 27, okay, 15. Yep, okay, all right. And then we have... man, wow, that doesn't seem right. Is that right? 5 times 4 is 25. Okay, yeah, all right. I guess it is right. My brain is off. 2 and then 6, and then we add this together. We have 7, 15, 18, and then 78.50 for that one. Over here, we're going to end up with, I'll just move that 0 off to the side. 3 times 4 is 12. Carry the 1. 3 and 4, and then 9. So 94.2. So let's take 94.20. That's 0, 7, 12, and then 17. So the answer should be 172.7 meters squared, which if we look at the book on page 380 is correct. So 172.7 meters squared. All right, sorry for the long video. Sometimes these multiplication and division algorithms just take a while. Main things: memorize these equations, memorize these equations. All right. If you guys have any questions, let me know on the school website, and I will see you in class.